Hello. Welcome back to IGCSE Fingertips. Today we are going to learn one topic which was already there in your curriculum, but before 2019 the way of asking these questions were different, and since 2020 the way of asking is also different. The topic is graph. We are going to study about types of graph, and we are going to study how shall we draw this kind of graphs. This was already there in your curriculum, but after they have introduced calculus, which is differentiation, they have somewhat changed the way of asking this kind of questions, right? So let us study those graphs first. So the first and foremost type of graph which we do have to study is a linear graph, right? A linear graph. Now guys, what do you mean by a linear graph? Linear graph means a graph which is in the form of y is equals to mx plus c, which means a graph which has a straight line. That is called a linear graph, right? Let's say this is my x and y axis. So even this would be a linear graph, this would be a linear graph, even this would be a linear graph, this is also a linear graph, and this is also a linear graph, right? Now how shall we draw this kind of graphs, or what points are important in this kind of graphs, right? So let us take an example first. Let's say I tell you to draw a graph of which is, let's say, y is equals to 3x plus let me take it simpler, 2x plus 8, or let's say I tell you to draw a graph of y is equals to negative x plus 3, or I tell you to draw a graph of y is equals to 4 or x is equals to negative 3. How shall we draw these four kinds of graphs? Now guys, you have to remember that if you're getting your graphs in this format, which is y equals to mx plus c, right, then this graphs are going to be your straight line graphs, where m is your gradient and c is your y-intercept. Y-intercept meaning the point where the graph crosses x-axis, sorry, not x-axis, the point where the graph crosses y-axis, right? And again, even x equals to some number or y equals to some number, that is again a straight line graph, right? So now what points are important, or what points are we supposed to plot in this kind of graphs? The most important point is, or are, their intercepts, that is their x-intercept and their y-intercept. If I have these 2 points, then I can simply draw a graph. Now what is x-intercept? X-intercept is a point where the graph crosses x-axis. That means at that point y is going to be 0, right? Because if this is your x-intercept, then at this point y is definitely going to be 0, and this is my y-intercept, meaning this is the point where my x is going to be 0. If I can somehow find these 2 points, then I can draw a straight line from these points, right? So let us first plot the graph y is equals to 2x plus 8, right? Now I'll first find the x-intercept and y-intercept. Now guys, what is my x-intercept? X-intercept is a point where my y is 0, right? So if I substitute y as 0, in this equation, I have 0 equals to 2x plus 8. So from here I can say x is negative 4. So I have my x-intercept as negative 4 comma 0. In the same way, for my y-intercept, I'll have to substitute x as 0. So let us 0 comma 8. Now let's say this is the graph. I'll have to first plot these points. So let's say this is negative 2, this is negative 4, and here I have 2, 4, 6, and maybe this is 8. So this is my first point, 0 comma 8, and this is my second point, negative 4 comma 0. Now use a scale and draw a straight line from here. That's it, right? That's it. Now this is the graph. This graph may be of 2 marks or maybe of 1 mark. Max to max it can go up to 3 marks, but that is next to impossible, right? So whenever they tell you to plot a straight line graph, right, sometimes they do tell you to mention the x-intercepts and the y-intercept, but I do recommend that you always mention the intercept even if they are not asking you, right? So it is a good way of you can always show the intercepts, and the graph could be easier for the paper checker to check, right? So you can plot this straight line using this method, right? What did I do? I found out the x and y intercepts, I plotted them on the graph, and using a scale I draw straight line. Same goes for this graph. Let's say this is my graph. I have to first find out the x intercept and y intercept. Now guys, what is my x intercept? X intercept is a point where my y is 0. So if I substitute y as 0, I'll have my x as 3. And when my x is 0, y is going to be 3. So for this line, let's say this is my graph. So I'll have to first find out the points 1, 2 and 3. And in the same way I have 1, 2 and 3. Now from these 2 points, this is my point 3, 0 and this is 0, 3. So using a scale, I'll draw a line. Right, that's it. You do need to understand this negative x. The sign negative indicates this is the slope is decreasing, right? The negative sign indicates that the gradient is decreasing, and the positive sign indicates that the gradient is increasing, right? In the same way, if they tell me to plot y equals to 4, now y equals to 4 means that whatever the value of x is, the value of y is always going to remain 4. Even if x is 2, 3, 4, 5, 6, whatever be the value of x, the value of y is always going to remain 4. So let's say this is 2, this is 4. So they are saying y equals to 4, meaning I'll draw a line from this parallel to x-axis. This shows that for any value of x, my y is always 4, right? In the same way, if they say x equals to -3, x equals to -3, then it means that for any value of y, your x is always going to be -3, even if y is 1, 2, 3, 4, 5, be it for any value of y, your x is always going to be -3. So this is how the graph is going to look like, right? So this is how you plot straight line graphs, right? This was the first type of graph which they ask, but this is not asked that frequently. Now the second kind of graph which we are going to discuss is our exponential curve. Exponential curve. Now what do you mean by exponential curve? Exponential curve means when I have a term which is y is equals to a raised to x, right, where a is a constant, right? Maybe if they tell me to plot y is equals to 2 raised to x or y is equals to 6 raised to x, this is a form of exponential curve, right? So now how shall we plot this kind of graphs? Now for this kind of graphs, I'll use a simple way of let me plot using the table function first, or let's say even if we do not use table function, let's say when x is 0 for this graph, when x is 0, y is going to be 2 raised to 0, that is y is 1. So when x is 0, the value of y is 1, right? Now when x is 1, y is going to be 2 raised to 1, that is 2. When x is 2, y is going to be 2 square, that is 4. When x is 3, y is going to be 2 cube, that is 8. Similarly, x is 4, y is going to be 16. X is 5, y is going to be 32. Now if you identify the pattern, see with the increase in x, the value of y is increasing significantly. It is getting, every time it is getting multiplied with 2. It was, when it was 0 it was 1, for 1 it was 2, for 2 it was 4, for 3 it is now 8, for 4 it is 16, for 5 it is 32. So for each value in increase of x, the y is increasing significantly. So let's say when you have x as 1, obviously your y is 2. When x is 2, y is 4. When x is 3, y is 8. So this graph is going to increase significantly, right, till it reaches a maximum value. Now, what about this left hand side? Right, the left hand side means, what about those points where my x is negative? Let's say when my x is minus 1, the graph is going to be y equals to 2 raised to minus 1. That is 1 over 2. That is 0.5. When x is minus 2, y is going to be 2 power minus 2. So x is negative 3, y is going to be 2 power minus 3. So guys, this is half, 1/4, 1/8. Now if you observe, if I am increasing the value of x in the negative direction, if I am increasing the value of value of x in the negative direction, the value of y is reducing 1/2. That is 0.5. Then I have 0.125. Sorry, 0.25. Then I have 0.125. Again, the value of x, when the value of x is increased negatively, the value of y is reducing, right? In such a way, if I take a very large value of x, maybe x raised to 10, or maybe even x raised to negative 100, the value of y would be very, very, very close to 0. It would be very, very close to 0, but it will not reach 0. So the graph is going to be somewhat like this. The graph would never touch the x-axis because it is never 0, but it is reaching towards 0. This is how your exponential curve is going to look like. This is called increasing exponential curve, right? Increasing means as the value of x is increasing, the value of y is increasing exponential. This is an increased exponential curve, right? Now in the same graph, if someone tells me to plot y is equals to 6 raised to x, again what I'll do, I start with x is 0. So if x is 0, obviously my y is going to be 1, right? If x is 0, my y is going to be 1. Now when x is 1, initially here the y was 2, but now y is going to be 6. When x is 2, in this equation y was 4, but here it is going to be 36 because 6 square 36. So this graph would be even more steeper than the previous one, right? And in the same way, it will also decrease very rapidly, right, with the increasing negative value of x, right? This is how the exponential curve is going to look like, right? This is an increasing exponential curve. Always do ensure that the graph do not touch the x-axis and you have mentioned the y-intercept. The graph should not touch x-axis and it should have a proper x-intercept, right? Next type of graph, even in exponential, there is one more kind of graph, that is decreasing exponential. Let's go to that first. Now, for exponential decrease form, let's say the graph is going to be y is equals to 2 raised to minus x, or y is equals to 3 raised to minus x, let's say, right? Now, how is this graph going to look like? Now, what will happen is you increase the value of x, right? Let's say when x is 0 for this graph, obviously y is going to be 1 because 2 raised to 0 is 1. When x is 1, y is going to be half because 2 raised to minus 1. 2 raised to minus 1 is 1/2. The same way when x is 2, y is going to be 1/4. When x is 3, y is going to be 1/8. So if you observe, as I'm increasing the value of x, the value of y is reducing significantly, right? The value of y is reducing significantly. So this is going to look like this. And what will happen if I place negative value of x? When x is negative 1, y will be 2 power minus of minus 1, that is plus 1. So y is going to be 2. When x is negative 2, y is going to be 2 power minus of minus 2, that is plus 2. So 4. When x is minus 3, y is going to be 8, and so on. So as you are increasing the value in negative direction of x, the values of y are also increasing. So the graph is going to look somewhat like this. This is the opposite graph of the previous one. This is the opposite graph of the previous one. You do need to remember the shape. The graph is going to go towards infinity, right? The graph is going to go towards infinity. This is your decreasing exponential curve. Same will be the case for 3 raised to minus 6, but it would be a bit steeper than the previous graph, right? It would be steeper than the previous graph. Also, this graph is not supposed to touch the x-axis, right? Okay, so this is all exponential graph is about. Again, now what is the shape do I need to remember? Just to give you a brief, this is one shape when your graph is a raised to x, right? And this is the second shape. This is when your graph is a raised to minus x, right? You can try this. In case you want to understand, you can also try half power x and half power negative x. You can draw this graph and see the shape. It would be similar to exponential curves, but a bit different, right? Now, moving to the next part of the curve, that is, next part of the graph, that is reciprocal graphs. It is reciprocal graphs. Now, guys, in reciprocal graphs, there are two kinds of graph that is important. The first one is y equals to 1 by x, and the second is y is equals to 1 by x square. Now, guys, what do you mean by reciprocal graphs? Reciprocal graphs means when you increase the value of x, the value of y is decreasing. When you increase the value of x, the value of y is decreasing. That is what reciprocal graphs is all about. Let's say this is a graph, right? Now what is going to happen? Now, guys, when x is 0, y is 1 by 0. Now 1 by 0 is something that is not defined, right? You cannot divide 1 by 0. So obviously this graph is never going to reach y-axis because 1 divided by 0 is something that is not defined. And when x is 1, y is going to be 1. When x is 2, y is going to be 1 by 2. X is 3, y is 1 by 3. So as we are increasing the value of x, the value of y is decreasing, right? So this graph is going to go like this, right? With the increasing x, the value of y is decreasing, right? Guys, this is called an asymptote, a point where the value of the graph is not defined, or the point where it reaches infinity. However, we use the word undefined. So the point where the graph, the values are not defined, that is called asymptote. Now this is called a vertical asymptote. Even in the same way, when x is infinity, y is going to be 0. Right? Why? Because when x is a very large value, maybe 1 by 1 lakh. So when x is 1 lakh, y is going to be 1 over. Right? When x is 100, y is going to be 1 by 100. When x is 1000 or 10,000, y is going to be 1 over 10,000. So 1 over 10,000 means a very small value, which is close to 0. Right? So even in this case, the graph is not supposed to touch x-axis. Why? Because it is never 0. It reaches towards 0. Right? Now, what about this was when the values of x is positive? What will happen when the values of x is negative? It would be a similar curve. When x is negative 1, even y is negative 1. When x is negative 2, y is negative half. When x is negative 3, y is negative 1 by 3. So the graph would look somewhat like this. The graph would look somewhat like this. This is the reciprocal curve, right? This is a reciprocal curve, kind of forming two different cup size or C, right? Forming C. This is a reciprocal curve. As you are negatively increasing the value of x, the value of y is reducing, right? This is called a reciprocal curve. Again, what if someone tells me to find, or someone tells me to draw y is equals to 2 raised to x? Now what will happen? Now with the increase in value of x, the y would reduce rapidly. So if someone tells me to plot y is equals to 2 by x, so this would even be a steeper curve than the previous one. This would be an even more steeper curve than the previous one. But again, this graph would not touch x-axis and the y-axis, right? This is my reciprocal graph. Guys, this is also known as hyperbola. This shape is also known as hyperbola. Now, the next form of reciprocal graph, that is y is equals to 1 by x square. Y is equals to 1 by x square. Now, this is very similar to the previous one, but with just small change. Now, what will happen when x is 1, y is going to be 1, right? Because this is 1 square. So when x is 1, y is going to be 1. When x is 2, y is going to be 1 by 4. When x is 3, y is going to be 1 by 9. This is the value of y are reducing at an even more rapid pace than the previous one, which was 1 by x. Why it is reducing at an even more faster pace? Because we have 1 by x square, right? So the value of y would reduce drastically. So with each increase in x, the value of y would reduce significantly. The value of y would reduce significantly, right? And now what will happen for the negative values of x? So again, when x is going to be minus 1, the same graph, 1, minus 2, 1 by 4, minus 3, 1 by 9. So there would not be any negative values of x. There would not be any negative values of x. So this is how your 1 by x square would look like. This is how your 1 by x square would look like. Again, please ensure that these graphs do not touch x-axis or the y-axis, because at that point the values are not defined, right? Because when x is 0, y is going to be 1 by 0. So it is forming an asymptote. Again, see, this is y is equals to 1 by x square. Now in the same graph, if someone tells me to plot 1 by x, right? So it would be a less steep graph than 1 by x. It would be a less steeper graph than 1 by x. Let me just plot it over here. The graph of 1 by x is going to look like this, right? A less steep curve than 1 by x square, because when I am increasing the value of x, the values of y is reducing significantly, right? Now the next two shapes are a quadratic curve. Quadratic curve means a curve where you have y is equals to ax square plus bx plus c. Yes, this is called a quadratic curve. Now guys, for the next two curves, which is quadratic and cubic curve, you need to have some idea about differentiation. I hope you do have some clarity. If you do not, you can tap the I button over here and you can go first, watch those videos first and then come back. It would give you a better understanding for this concept. Right. Now, let's say a curve which is in the form, or an equation which is in the form of ax square plus bx plus c. Right. Now, even if you draw these kind of curves, this is going to form a U shape or a bell-shaped curve. Not bell-shaped curve, sorry, a U-shaped curve, right? A parabola, a quadratic curve which is in the form of ax square plus bx plus c. Its general shape is something like a U-shaped curve, right? This U-shaped curve, guys, is called parabola. This U-shaped curve is called parabola. Right, this U-shaped curve is called parabola. Now, what are the points that are important to plot in a parabola? There are few points which you need to consider. The first is these points. Right. Now, what are these points, guys? These points are known as my x-intercepts, which means the points where the graph crosses x-axis. This is my y-intercept, which means the points where my graph crosses y-axis. And this point, guys, this point is my stationary point or my turning point, or you can say the vertex of the graph, right? Now guys, what do you mean by stationary points or turning points? The points where the graph, or where the point where the gradient, which is dy by dx, is 0. These points are known as stationary points. The points where dy by dx is 0. I hope if you are here now, then you have already watched the video on differentiation, not on integration. You have already watched the video on differentiation, right? So this point is known as stationary points or the turning point. Y-intercept and x-intercept. Somehow, if I somehow know, let's say this is my x-intercept, this is my y-intercept, and for example, and this is where my turning point is, or this is where my y-intercept is. So using these 4 points, I can simply draw a U-shaped curve. From these 4 points, I can simply draw a U-shaped curve. You need to remember that this is the line of symmetry as well, or the graph would be symmetric from these two halves. The graph would be equally divided into these two halves from the turning point or from the stationary points or from the vertex. The graph is symmetric in nature, right? Now, so for this kind of questions, we would solve some of the questions. I have already attached few of the questions. For this questions, we would solve them directly. But you need to understand that in order to plot these points, I need to know the x-intercept, the y-intercept, and the stationary point. If I have those values, then I can easily plot. Now, the next shape of curve is cubic curve, or a curve which is in the form of, or an equation which is in the form of ax cube plus bx square plus c. Right, this is the last type of curve known as cubic curve. Right, now what is the general shape of a cubic curve? Guys, a cubic curve generally looks like this, or it may also look like this, or right, or it may also look like this. These are 3 different cubic curves. Now guys, what are the important points in a cubic curve? See, first of all, these points. What are these points? The points which I have marked in red, or see, even these points for the black graph. See, these points are the points which I have marked in red. The points which I have marked in red. What are these points? These points are nothing but the x-intercepts, meaning the point where the graph crosses x-axis. Right. Now, what are the other important points? What are the other important points? Let's say these 2 points. These 2 points. This one and this one again, even with this one and this one. So, what are these points, guys? These points are my turning points, right? Why turning points? This is where my gradient is 0. If you observe, the gradient is increasing, and at this point it is reaching its maximum value. The gradient is reaching its maximum value, or after this, at this exactly this point, it is reaching the value of, as you are increasing x, the value of y is increasing, and this is called the maxima or maximum. And at this point, if I draw a tangent, its gradient will be 0. So this is why it's a turning point. Now what will happen after this point? Obviously the value of y is reducing. So these 2 are my turning points. When the graph turns, either it turns like this, or like this. The graph basically turns. So again, this is also a turning point. These 2 points are my turning points, and even these 2 points are turning point. In the same way, you can also say these 2 points are turning point. So if you have the x-intercept, if you have the turning points, and if I have the y-intercept, I can plot the graph very easily. But it is not necessary that always you might have all the points, right? But even with some of the points, I can plot the graph smoothly, right? Let's say this is my intercepts, and I know that this is where my turning points are. Then I can draw a graph even without having to find the intercept, right? This is how I can draw my graph, right? This is how I can draw my graph. Now, this was all the graphs is about. Let us understand them in a better way with the questions. Now, see, whenever they have cubic equation, it is generally associated with some subparts. You will not be directly said to draw a cubic curve, right? If they say you directly, then there would be some form of information given to you. Let's say, let us understand this question. Now, what I have been told, find the coordinates of the point where the graph crosses x-axis, where the graph crosses x-axis. So, when the graph is crossing x-axis, it means the value of y is going, the value of y is going to be 0, which means x into x minus 1 into x minus 2 equals to 0. Now, when is this possible? Obviously, this is only possible when x is 0 or x minus 1 is 0 or x minus 2 is 0. So, 0 comma 0, when x is 0, y is 0. Here, x is 1, y is 0. Here, x is 2 and y is 0. So, these are the points where the graph is crossing x-axis. For the next part, I have to show that f of x is equals to this. Guys, this is nothing but the expansion of the above curve. I hope that you can do that easily. You don't need my help for that. Next, find the coordinates of the turning points. Right? Now, what do you mean by turning points? Turning points are the point where your gradient is 0. That is dy by dx is 0. So, what is my dy by dx for this graph? It is 3x square minus 6x plus 2. Right? Turning points are the points where your dy by dx is 0. Now I'll have to factorize this. How can I factorize this? I'll have to split the middle term. So I'll have to split the middle term in such a way that on addition I should get negative 6 and on multiplication I should get positive 6. Now, what are those terms? I think minus 3x minus 2x. Sorry, I think my bad. 3x square minus 6x plus just a second, I think I have made a small mistake. 3x square, okay, minus 6x plus 2. Okay, so on addition I should get maybe negative 6 and on I have to give my answer up to 1 dB. I don't think this can be factorized. So what I'll have to do is I'll have to apply the quadratic formula. I'll have to apply the quadratic formula. Right? I'll have to apply the quadratic formula. Now what does the quadratic formula states? The quadratic formula states that x equals to minus b plus minus root b square minus 4ac over 2a. So my x is going to be negative of b plus minus root b square minus 4 a into c over 2 times of a, that is 2 times of 3. So 6 plus minus root 6 square is 36, 4 3s are 12, 12 2s are 24. So I have 36 minus 24 over 6. So I can write this as 6 plus minus root 12 over 6. Right? I can simplify, or I can write root 2 as 2 root 3. I can write root 12 as 2 root 3. How? Because 12 is what? 2, 6, 2, 3, 3, 1. So this is 2 root 3. Right? So I can further simplify this as 6 plus minus 2 root 2 by 6. 2 root 3 by 6. Or if I take 2 common, I have 3 plus minus root 2 by 3. So one value of x is 3 plus root 2 by 3 and the other value is 3 minus root 2 by 3. Guys, I do not have the calculator with me, so but I do hope that, let me do one thing, let me find my calculator, I'll be back in a minute. So guys, I'm back with the calculator. Let me solve this equation. The equation was 3, negative 6 and 2. So the answer I have to give up to 1 decimal place, right? So to give you a better answer, it is 1.6 and the second value is 0.4. Right? These are the x value. Now obviously I have to find the coordinates, so I will have to substitute the value of x. in the main equation, right? What is my main equation, guys? This is my main equation. So when x is 1.6, y is going to be 1.6 cube minus 3 times of 1.6 square plus 2 times of 1.6. So 1.6 cube minus 3 times of 1.6 square plus 2 times of 1.6. So the value of y is minus 0.384. The value of y is minus 0.384. But as I have to write up to 1 decimal place, so it is going to be negative 0.4. In the same way, I'll substitute minus 0.4 in the main equation. So if I substitute 0.4 in the main equation, right, which is this equation, so you have your value of y as 0.4 cube minus 3 times of 0.4 square plus 2 times of 0.4. So let me do that as well. 0.4, you have 0.4 square, and you also have 0.4 cube. So at this point the value of y is positive 0.384, or I read it as 0.4. Right, now the next part would be to plot the graph. Now they are saying sketch the value of y. Now guys, what do I have now? See, I do know that the turning points are 1.6 comma negative 0.4 and 0.4 comma 0.4. Again, what other information do I have? I do have the x-intercepts, that is 0, 0, 1, 0 and 2, 0. The x-intercepts are 0, 0, 1, 0 and 2, 0. Now what I'll do, guys, I'll simply plot these values in the graph and try to find the shape of the curve. See, first I'll plot these two graphs. So I have 0, 0. Let's say this is my 1, this is my 2. So 1, 0, and let me take a better scale for the graph. Let's say this is my 0, this is 1 and this is 2. So 0, 1 and 2. These are my turning points. Now you have at 1.6, which is somewhere between 1 and 1.2, I have negative 0.4. So when x is, let's say, 1.6, the value of y is minus 0.4. Right? Value of y is minus 0.4. And when x is 0.4, the value of y is positive 0.4. So I'll draw, let's say, somewhere over here. So this is my point. So now what I'll do, I'll draw a curve. See, these are my x-intercepts and these are my turning points. So now I have a curve which goes, like this. Right? This is what my curve is going to look like. Please ensure that you have properly labeled all the points. Now this graph was only of 2 marks. Why it was of 2 marks? Because we had already found out all the values that was required for the question. Again, see, draw a plot of y is equals to 1 by x. Right? This is a reciprocal curve. Right? Simple. Next, y is equals to 4 by x. 4 power x. This is an exponential curve. 1. And it is going to go like this. That's it. Exponential curve. Next, I have to draw 2 by x. Again, 2 by x is a reciprocal curve. So 2 by x. 2 power negative x. This is a decaying exponential curve or a reducing exponential curve. Guys, the increasing exponential curve looks like this, but the reducing exponential curve looks like this. Right? Just do plot that this is 1. Right? Do plot that this is 1. Next question. Again, I have to show that the equation of y is equals to x cube minus 4x plus 4 can be written as y is equals to x into x minus 4 whole square. Now what shall I do? Shall I take x common? Yes. So I have x square minus 4x plus 4. Now I think I can factorize this, right? But I can already see this is nothing but square of x minus 2, right? Because x minus 2 whole square, that is a minus b whole square. This is in the form of a minus b whole square, that is a square minus 2ab plus b square. So x square minus 2 times of 2x, that is 4x plus 2 square. Now guys, what is my a? The value of a is 2. Next, on the axis, sketch the graph indicating the value where the graph meets the axis, right? So now, where does the graph meets axis? Though meeting the axis means when your first let us find out the x-intercept, which means the points where y is 0. So when y is 0 is equals to x into x minus 2 square. This is only possible when x is 0 or when x minus 2 square is 0, or you can say when x is 2. So one intercept is 0, and let's say this is my 1, this is my 2, this is my second intercept. So there are only 2 intercepts at this point. Now what is my y-intercept? I think y-intercept is when x is 0. So if I substitute x as 0, y is also going to be 0. So the graph definitely passes through origin. Now guys, the question is the shape of the graph. I know these two are my x-intercepts. Now how will the shape of the graph looks like? So this is a 4-marker question. So what I'll do, I'll try to find the turning points. Now what are the turning points? Again, turning points are the points where your dy by dx is 0. So I'll do find out dy by dx, that is 3x square minus 8x plus 4, right? 3x square minus 8x plus 4. Is there any way that you can factorize this? 4 3s are 12 and negative 8, let me just, yes, I have to factorize this in such a way that on addition I should get negative 8 and on multiplication I should get 12. I think that is negative 6x and negative 2x. Now I can take 3x common, so I have x minus 2, negative 2 common, again x minus 2. So x minus 2 into 3x minus 2. So x is 2 and x is 2 by 3. Guys, these are my turning points. So x equals to 2, this is a turning point, right? This is a turning point, and 2 by 3, which is 0.667. There is one more turning point somewhere over here, right? Now, what is the value of x when, what is the value of y when x is 2 by 3? Let us find that. So y equals to 2 by 3 cube minus 4 into 2 by 3 square plus 4 into 2 by 3. So you have 2 by 3 cube minus 4 times of 2 by 3 square plus 4 times of 2 by 3. That is 32 by 27, which means it clearly indicates the y-intercept is positive. Now what does positive y-intercept indicate? That the graph is going to go upwards till the maximum point and then it is going to go downwards, right? The graph is going to go upwards, which means see. Now these are my x-intercept. Now one of the intercept is also a turning point. So, and this is also one more turning point. So the graph is going to go upwards till it reaches a maximum value, and it is going to go downwards and then again turn to the opposite direction. This is how my graph is going to look like. What did I do? I plotted the turning points. These are my turning points. Let me label them in a different shape. These are my turning points. In fact, the orange one are also my x-intercept. So one of the intercept is also a turning point, right? So this is going to go like this. Next question. Now again, I think I have, let us skip the A part. What do I have? I think I have to show that x square plus 4x plus 1 in the form of this. So this is called completing the square, guys. what I'll do, I'll have to expand and compare the coefficient. So let me expand this first. This is a plus b whole square. That is a square plus 2ab plus b square. Now after doing this, I need to compare the coefficient. The coefficient of x square is 1 and here also it is 1. The coefficient of x is 4 over here and here I have 2p. So I can say p is 2. Now the constant term means the term which does not contain x, that is 1 over here and here it is p square plus q. So 1 is equals to 4 plus q, so q is negative 3. So now this form is x plus 2 square minus 3. Right. Now in the next part I have been told to solve the equation. I think you can solve this pretty easy. So I have x plus 2 square equals to 3, x plus 2 is equals to plus minus root 3 and I can say x is plus minus root 3 minus 2. So I have two values of x. The first is root 3 minus 2 and the second is negative root 3 minus 2. Right. Now the next part would be sketching. I think, oh, I do have to find the minimum points as well. Okay, let us find the minimum points. Minimum points means the turning point. So dy by dx equals to 0. That is 2x plus 4 equals to 0. This is when x is 2x equals to negative 4, x is negative 2. So when x is negative 2, the value of y is negative 2 square plus 4 times of negative 2 plus 1. 4 minus 8 plus 1. 5 minus 8 is negative 3. Right. So now I also have my turning points. Now what am I supposed to do? I am supposed to sketch the graph. Right. Now guys, let's say this is 1, this is 2, this is 3, this is negative 1, this is negative 2 and I have negative 3. Now what are my turning points? The turning points are negative 2 comma negative 3. So I'll have my turning points over here. I do have to plot the intercepts as well. The first intercept is root 3 minus 2, that is minus 0.26, or let me add it here, minus 0.268 and the second intercept is minus 3.73. So I say that I was supposed to write no. Okay. So I have minus 0.268 which is somewhere over here and I have negative 3.73. Let's say this is my negative 4 and this is somewhere over here. So these are my 3 points. So that's it. You draw a graph and you are done. Even when x is 0, if you want to find out your y-intercept, when x is 0, y is going to be 1. So this is my point. Label them and you are done. Also, one more tip. The midpoint of x-intercepts. The midpoint of x-intercept is going to be your turning point. The midpoint of x-intercept is going to be your turning point. Also, if you have a quadratic equation which is in the form of ax square plus bx plus c, the simplest way to find out turning point is the turning point which is x is going to be negative b over 2a. This is the value for turning point of x, which means let's say this was the equation. If they simply tells me to find out the turning point which is negative b over 2a, what is the value of b over here guys? 4. So minus 4. What is a? 1. 2 into 1. So again negative 2. Yes, right. This is matching. This is a small tip to help you out. And I think I do have the last question. I think the last question is again somewhat same. On the sketch I have to show the turning points. Let me do one thing. Let me first write this in this form. Again what I'll do, I'll have to compare the coefficients, right? Because a plus b whole square, a square plus 2ab plus b square. So I have b minus a square minus 2x minus x square. So the coefficient of x square is minus 1. The coefficient of x is minus 2a. the coefficient is minus 3. A is equals to 3 by 2. Now the constant term, which the term does not have x, that is 18 over here, and here I have b minus a square. So 18 is equals to b minus 3 by 2 square. So 18 plus 9 by 4 equals to b. So 18 plus 9 by 4, that is 81 by 4. So the value of b is 81 by 4. So the points are going to be 81 by 4 minus 3 by 2 plus x square. Right, this is my point. Now, next part, what I have been told, I have to sketch the graph indicating the turning points. Right, again, what are the turning points? Let's say I'll simply use the formula. Turning points is minus b over 2a. What is my b, guys? B is minus 3. So, minus 3 over 2 times of a. What is a? Negative 1. So, that is 3 by, just a second, what is b? B is negative 3 and a is negative 1. So, minus minus plus, and this is minus, yes. So, 3 over minus 2, or the turning point is negative 3 by 2. So the turning point is negative 3 by 2. Guys, just a small help. You can also find the turning point using completing the square method, right? You can also find the turning points. There are 3 ways to find turning points. First is dy by dx. The second is minus b by 2a. And the third is by using completing the square. Now, if you don't want to get into all this hassle, you simply do dy by dx equals to 0. Find the value of x, substitute the value of x in the main equation, you will get your y. So when you substitute the value of x in the main equation, you will get your answer is 81 by 4. Right. So now, obviously, I'll have let's say this is negative 1, this is negative 2. So the value of let me just make some graph at a just a second. Let's say I have negative 1, I have negative 2, negative 3 by 2, that is somewhere over here, right? And 81 by 4. So it shows that the graph is going somewhere here, right? And what are my intercepts? Can I find the intercepts? I think I can. This question is of, let's see, this question is of 3 marks. So it is better that you do find the intercept, which means you'll have to find, if you can find the intercept, it would be better. Now, intercepts means the point where the graph crosses x-axis. So you can find the intercept. You can also find the intercept using completing the square method. I am leaving that for you. For now, I am telling you that the intercepts are x is equals to 3 and x equals to negative 6. So I'll have to plot, I'll have to extend this line. Let me just extend this line. Let's say this is my negative 6 and this is my 3. So from these two, this is my first point, this is my second point, and this is my third point. So from these 2 points, these 3 points, I'll draw a U-shaped parabola. Now, with this, guys, we are done with the topic. Hope you have understood. Please let me know in the comment box below if you want to, maybe increase the pace, decrease the pace. You need more form of questions. You need more questions of this topic or any other suggestions. All the suggestions are welcome. Bye bye. Have a great day.